The 2016 got harder though.
Yeah, it does. Some of them are hard. All right, here we go. Number 22. This is the 2015 rest of the non-calculator. So go back to the 2015, the rest of the non-calculator. Look on with me, if you would, if you got your Chrome dogs up, because it makes more sense when you can see the problem yourself too. And then we'll go to the 2016 multiple choice with the calculator. So in a minute, we're going to have a calculator. Here we go. Let f be a function given by f of x is equal to kx over x squared plus 1, where k is a constant. For what values of k, if any, is f strictly decreasing on the interval from -1 to 1. So you have f. You want to figure out where f is increasing or decreasing. Actually, they want to know where it's decreasing. So we just got to find the what. How do you figure out if something is increasing or decreasing?
It's negative.
Yep, where the derivative is negative. So we have to find the first derivative. So I'm going to find the first derivative, which is going to require what rule for kx over x squared plus 1? Quotient rule. So we got k times x squared plus 1. Okay, that's the derivative of the top times the bottom. Minus the top, kx, times the derivative of the bottom, which will just be a 2x, over the bottom squared. So what we end up with for the derivative is this. We end up with, on top, we distribute collect like terms. We're going to get kx squared plus k minus 2kx squared over the bottom squared. The top ends up giving me negative 2k, because these two are like terms. Sorry, it ends up giving me negative k, because you have 1 here and minus 2. It'd be negative 1kx squared plus k over x squared plus 1 quantity squared. Now, this is my first derivative. If I want to do a sign analysis for the first derivative and figure out where it's increasing and decreasing, I got to know critical values. Critical values is where the first derivative, okay, critical values for f prime is where the first derivative equals 0, which is where the top would equal 0. So negative kx squared plus k equals 0. And then the first derivative is undefined, which is a point of non-differentiability for the original function, where the bottom equals 0. Now the bottom, when you set the bottom equal to 0, you only have to set x squared plus 1 equal to 0, because the squared part on the outside, people are like, what do I do with it? You can just take square root of both sides and get rid of it, and you're just going to end up with x squared plus 1 equals 0. So people always ask me, why do I drop the squared so quick? It's because you're going to take square root of both sides, and the square root of 0 is 0. Plus or minus 0 is just plus or minus 0. All right, now, this right here is not going to give you anything. This part right here, this is not going to give you anything, because you're going to get x squared equals negative 1. Take square root of both sides. You're going to get x equals plus or minus I. So there's no critical values. There's no place where the first derivative is undefined. You don't even have to worry about that. And most of you can look at that and just tell this is a parabola shifted up one. It never crossed the x-axis. It's a parabola shifted up one. It's all positive. It's opening up. It never crossed the x-axis. So there would be no zeros. This will have zeros. You can factor out, I'd factor out a negative k. So you end up with x squared minus 1. This is just a constant, so that doesn't give you anything, but you get critical values of plus or minus 1. So the k is the constant. That don't even matter. Okay. All right, so then it says what values, for any values of k, if any, is it strictly increasing or decreasing? Well, we know the critical values are 1 or negative 1.
So would it just be D or E?
Yeah, it's going to have to be D or E. So it's going to be from negative infinity to negative 1. It'd be from negative 1 to 1, and it'd be from 1 to infinity. Now, I'm going to do it, but it's obvious that it can't be 0. So it has to be 1 or negative 1. It looks like it's going to be 1. So if k is positive 1, if k is positive 1, and if I do a test value of 2 here, let's test 2. because 2 is between 1 and infinity. So if I test, you got to pick a test value. You could have tested 0, I guess. Let's test 0, fine. Because that's probably what most of you are going to test. You're going to test x equals 0 since it's between. All right, if I test 0 here, 0 is going to make this negative. And then if I let k equal 1, that'd make a negative. A negative times a negative is a what? And then signs would alternate. Confused here.
But why would they? Wouldn't it be multiplicity 2?
Where at? This would be multiplicity 2 if it had solutions, but that doesn't have solutions. Up here is multiplicity 1, so I get k equals plus or minus 1.
Where it used to be E now?
Well, it says for any values of k is f, if f is strictly decreasing, and it's not strictly decreasing. Okay, you have a positive, you have a negative, you have a negative. Strictly decreasing means it's decreasing over the whole thing, but we have somewhere it's increasing. So the answer is E. There are no such values. Thank you. I was not reading the question. So a little tougher problem. So you got to think about it. This one right here, which of the following is an equation for the line tangent to the graph? Now, before I go any further, what do you need to be able to do a tangent line? Point and a slope. So we need a point and we need a slope. And then they give us this equation, y equals 3 minus the definite integral from -1 to x of e to the negative t to the third dt at the point x equals -1. So we want to know the tangent line at x equals -1. So I need to know, if this is my original equation, I need to know y of -1, and then I need to know y prime of -1. So I need to know a point and a slope. Point, you use the original equation, the OG, which over here is the y equation. That's the original. And then slope, I need y prime. So first of all, the point, you would just use this equation. It would be 3 minus the definite integral from 1 to -1 of e to the negative t to the third dt. Now, since you learned integration by substitution, even though most of you need me to kind of reteach it today, I'm going to do integration by substitution. Okay, y of -1, it's going to be 3. Now, are your limits of integration allowed to be this way? Where does the smaller number have to be? You got to flip it and then make it negative, and there's already a negative out front. So I'm going to swap these and then make it negative, which will make a positive. So we'll have from -1 to 1, and you're going to do that quite a bit now, of e to the negative t to the third dt. Now we can use integration by substitution. All right. You just learned it, not yesterday, but the day before. And what you do is you do what's called u substitution. You let u be the inside of the most complicated part that you would need chain rule for. Obviously, we're going to need chain rule for this. Do you see that? Does everybody see that?
Yeah.
Okay. This is non-calculator, correct?
Yeah.
And it's really negative t to the third. Correct? Interesting. Because I think this requires integration by parts, which you guys don't know. I bet this, wait a second, this is the 2015 practice exam, correct?
Yeah.
All right, let me just try it.
Is this the one with the free response?
Yeah, free response on it. Yep, it's got free response. We did the first two.
Yeah.
Yeah, we're going to work on some over break.
Tough one.
Yep. I looked at the non-calculator. They're not that bad because I was mad about the other ones. All right, negative t to the third.
Free response.
We're going to let u be the inside of the most complicated part. Then what you did, and I'll explain this today, is you go to du dt. You do the derivative of each side. That'll give you negative 3t squared. And then you multiply both sides by dt. To separate the variables. So you get du is equal to negative 3t squared dt. So this is your u substitution part. Okay, and I don't know how far she got and how far you guys got in the video, but
Oh, that was so dumb.
Yeah, I'll go through it though today. I'm going to just reteach
She
it.
just like didn't go over the lesson first. You know what I mean? You know the page where you like explain everything?
Yeah, I'll go over it again today.
Or anything.
All right, so here we go. We have an integration by substitution. So we're going to let u be this. Here's the part I'm having a hard time with is this seems like it needs integration by parts. So we're going to have e to the u because I'm going to let u replace this. Okay, so that takes care of that. But then I need to get rid of the dt, and I've got this negative 3t squared. That's the part I'm having a hard time with. I swear I think this needs integration by parts.
Isn't that like
Don't you gotta like
going to the U
divide
or
the whole
something?
thing by like a negative one?
Yeah, but the problem is there's no x out here. This is on the calculator, non-calculator.
Yeah, this is
See, I can do the derivative easy. The slope part's going to be easy. It's this integration by substitution part that I'm confused on because this gives you u as that, so I replace this. Okay, so that's gone. Now I have a dt. dt would get replaced with, you would have to solve for dt, so you'd have a negative 1/3 t squared du is equal to dt. But the problem is there's no t squared outside.
Look at the answers, see if you can tell from them.
What am I not thinking about here? I'm going to come back to this specific problem in class. I'm going to come back. It's going to be first problem. I'm going to do this problem in class to show you why integration by substitution is used. I need to look at this. The derivative part will be easy. I can actually do that because when you do the derivative of the accumulation function, you use FTC part 1. FTC part 1. So the derivative is actually easy. Watch this. The derivative of this would be, what's the derivative of a constant? 0. And then when you do the derivative of this, you just plug what in? Just plug in the x. So you're going to have negative e to the negative x cubed. And that's it. That's the derivative. You just plug in x, and then the derivative of x is just 1. So you don't need chain rule with it because it's just an x up there. And so the derivative is actually really easy. So then you can plug. So this is the derivative y prime of x. And now I can use that to find y prime of negative 1. So it'd be negative e to the negative, the opposite of negative 1 cubed, which would be negative e to the, that's negative 1 cubed is going to be a negative times a negative is a, so it's going to be e to the first, so it's just negative e. Let's see if we can just by process of elimination. Yeah, look at that. You can get rid of that one because the slope has to be e. Get rid of that one, get rid of that one, get rid of, wait a second.
Why'd you get rid of B?
Sorry, it's negative e, isn't it?
Yeah.
So the only possible answer is B. So I want to figure out,
Wait, why can't you do that in the beginning? Or why were you doing
It
the
couldn't
other
be
part?
negative.
because remember, if you want to line tangent to the graph,
Oh, you were doing the,
I was doing the point first, and I got stuck on the point. I think this needs integration by parts. I'm going to check just to make sure. So I don't think you can do this right here, this FTC part 2 with integration by substitution because it needs something you're not going to learn to calc 2. But you can do the slope, and the slope's pretty easy to do. You end up with negative e, and there's only one answer with negative e. But that bothers me because they should be able to complete the whole problem. So I'm going to look at that. All right, 24. This right here, differential equation. This is where you solve for y. All right, watch this. We're going to do this next Tuesday with slope fields, dy dx. I've already taught you how to do this, but I've done easy ones. Okay, the first step, if you want to solve a differential equation, is the goal is to solve for y. It's to figure out what y equals. You're looking for a y equals equation. They give you a point so you can find the plus c. So here's what we're going to do. We're going to separate the variables first, so watch carefully. Okay, I'm going to move the dx over, so I multiply both sides by dx. I get dy is equal to 5y squared dx. Okay, I separated, but I've got to move the y over now. So I'm going to get 1 over y squared dy is equal to 5 dx. Now we do the integral of both sides. I can't do the integral of 1 over y squared, so I'm going to make that y to the negative 2 dy so I can integrate it. And then 5 dx will be easy because it's just a constant. That's not going to be a big deal at all. All right, what's the integral of y to the negative 2? What do? What's the first rule on simple power rule? Add 1 back, so you're going to have y to the negative 1 and divide by the new exponent. Okay? There's a plus c, but I'm going to plop it over together on the other side with the plus c. What's the integral of 5? 5x plus c. You're almost home free. So then this ends up being negative. I'm going to put the y on bottom, and I'll just put the negative out to the side. Negative 1 over y is equal to 5x plus c. Remember, the goal is to solve for y? The goal is to solve for y, correct? So I can, if I want to get y to the top, I need a flip. Well, you could, or you could just, there's a trick. You could multiply by y and then divide by 5x plus c. But can I just flip both sides? Can I just do the reciprocal of both sides? If I flip this side, I get negative y equals 1 over 5x plus c. Divide by negative, I get y equals negative 1 over 5x plus c. So now I can find the plus c, which, by the way, everybody can look at the answers and see, okay, it's not going to be A, it's not going to be B, it's not going to be C, it's either going to be D or E. I just need to figure out what that plus C is. That plus C right here, 0, 3. You ready?
So you plug 0 in for x and
Plug 0 in for x and set it equal to 3. So the initial condition, y of 0 equals 3, I'm going to set it equal to 3 and plug 0 in. So I'm going to get negative 1 over 5 times 0 plus c. It's simple. Set it equal to 3, plug in 0 for x. So I'm going to get negative 1 over c. Multiply both sides by c. I get 3c is equal to negative 1. What's c equal?
negative 1/3.
Negative 1/3. Agreed? Pretty simple. So now my equation is y equals negative 1 over 5x minus 1/3. I don't see that answer. So probably what they did is they cleared out the fractions. How can you clear out the fraction out of a fraction?
Just bring it to the top.
Multiply by 3 on bottom and multiply by what on top?
3.
You got to multiply by the least common denominator. We've done that before. You multiply top and bottom by the least common denominator. So I'm going to get y equals negative 3 over, if you distribute this, you'll get 15x minus 1. Why didn't I get a negative? Oh, look. Oh, they are shysty. Do you see mine's 15x minus 1?
Mm-hmm.
Do you see theirs is 1 minus 15x?
Oh, so they just,
They switched the signs on top and bottom. So they made it positive 3 on top and then made it 1 minus 15x. That's a jerk move. Yeah,
I hate this. I hate this.
that one's tough.
So 24.
Yep, D. That was tough. Okay, a couple more on this one, and then we'll go to the other one. This one's a simple one. If you miss this one, I'm going to be actually mad. Okay? You will get this after you see it a couple times. This is the definition of a derivative that you're supposed to memorize. The limit as h approaches 0 of f of x plus h minus f of x over what? This means find a derivative. Find a derivative of what? Whatever the function is. The function is what?
Sin x.
Sine. So they want you to find the derivative of sine x, but not just find the derivative of sine x. Find the derivative of sine x at what?
Power of 3.
So they want you to find the derivative of sine x at pi over 3. So they just want to know what f prime of pi over 3 is.
Hold on for 1 second. Could you just go up and look at that answer, the last answer, really quick? Okay.
You see what you did?
Yeah, I just had to finish writing it.
Oh, okay. So you just need, okay. So does everybody see this? This derivative? This is the derivative rule. So once you see it, you're just like, okay, what am I taking the derivative of? It's always right there. It's always the minus part. So I'm taking the derivative of sine x, but at pi over 3. They want to do the derivative of sine with pi over 3 plugged in. What is the derivative of sine?
Negative cosine.
No, positive cosine.
Positive cosine.
And then plug in pi over 3. So be cosine of pi over 3. Unit circle work. What's cosine of pi over 3?
1/2.
1/2. The answer's B. That one's easy.
Wait,
They're going to have one of those where they have that's why I make you memorize the definition of the derivatives.
wait, so did you do
Which
anything
we're
with the
not doing,
limit of h
right?
approaches 0?
No, you don't need to because you just recognize. I told you never have to use the long way anymore. You just need to recognize that this means a derivative, that's what it does. It calculates a derivative. Once you realize that's what it calculates, you go to this part of the formula, which is f of x, and that's you recognize which function you're taking the derivative of. So I'm taking the derivative of sine x. So I do the derivative of sine x, which is cosine, but they also want you to plug pi over 3. So they're not just asking you to find the derivative.
You have to do
They're-
anything about the negative.
What negative?
Well, it's minus sign.
That's the formula. It's supposed to be minus. Yep, so you just have to know the formula. Okay, next one. An object travels in a straight line for any time t greater than or equal to 0. Its velocity is given by this. Oh, this is awesome too. This is an easy one. An object moves along a straight line so that its time t greater than or equal to 0 is given by velocity is equal to 2 cosine 3t. What is the distance traveled by the object? So distance traveled, so really displacement, okay? But they're not asking which direction, so it could be positive displacement, it could be negative. But they just want to know the distance traveled. Distance traveled, we don't care about if displacement's positive or negative. Okay, so if the displacement's positive, we just say, like if it's positive 2, we say it traveled a distance of 2. If the displacement's negative 2, we'll say it traveled a distance of positive 2 still. Okay, the positive or negative just tells you which direction you're going is all. Okay, and we want to do this at the first time that it stops. So what I'm going to do to figure out when it stops, first of all, how would I figure out where it stops?
Sign analysis.
Don't even need to go that far.
Oh, 0?
Just find the-
Just figure out where it equals 0. Take v of t and set it equal to 0. So I'm going to take 2 cosine of 3t and set it equal to 0. And I want the first time that it stops. Because we know when we solve a trig equation, there's an infinite number of solutions because the unit circle goes on forever. So divide both sides by 2. If you divide by 2, 0 divided by 2 just cancels, right? So we get cosine of 3t is equal to 0. Now we do the inverse cosine. So if I do the inverse cosine, we're going to get 3t, because you cancel out the cosine, is equal to inverse cosine of 0. All right, we want the first place. So what's the first place cosine equals 0 on the unit circle?
Pi over 2.
Pi over 2. So we get 3t is equal to pi over 2. Divide by 3. If you divide by 3, it's the same thing as multiplying by 1/3. So what do you get? What's the first value? Pi over 6. Now, they want the distance traveled. So it'd be so easy to want to go answer B, but that's not the answer. They want to know what is the distance traveled from 0 to the first time it stops. So if we want distance traveled, we got to integrate velocity to get back to the displacement of position. So you're going to go the integral from 0 to pi over 6 of 2 cosine 3t dt. I can definitely do integration by substitution on this one. Some of you could guess and check this one, though. Let's just guess and check this one. This one's too easy. You can pull the what out front?
The 2.
The 2. The integral from 0 to pi over 6 of cosine of 3t dt. All right, what's the integral of cosine 3t? What would you take the derivative of to get cosine 3t?
You just sign.
Regular sine. Yeah, we're going to practice that. I'm not going to get you because...
Getting, like, tripped up with the derivative and integral.
Yeah, you just got to remember, we're going in reverse. What do we take the derivative of to get cosine? Now, here's the deal. If you took the derivative, pay attention, and we're guessing checking. If you took the derivative of sine 3t, you would get cosine 3t, right?
Yep.
But there would also be a derivative of the inside. What's the derivative of the inside?
3.
But there is no 3 up here, so what must have happened?
I cancel.
1/3, so make that 2/3 out there. And then evaluate it from 0 to pi over 6. So we're going to get 2/3. There you go, FTC. Which one do you plug in first? So we're going to have sine of 3 times pi over 6 minus sine of 3 times 0. Good morning.
Oh, Ava might be watching.
All right, what's 3 times pi over 6?
Power of 2.
Pi over 2. Minus sine of 0. All right, sine of pi over 2 is 1, I believe. Minus sine of 0 is 0. So you're going to have 2/3 times 1, which ends up being a distance of 2/3. So the answer is 2/3. So the answer is C. All right, 2 more, and then we'll go to the 26. Or the 16. 27. Very quickly. The table above, hopefully this is helping because some of you said you guessed on some of these. The table above gives selected values for a differentiable decreasing function. So we expect this just to keep going down. It's not going to go down and then back up. Like the fact that we're on the 2015, we're finishing the calculator or non-calculator, and then we're going to go to this 2016 calculator in just a second.
Which one did we do this? Oh,
Yep. So we're going back and finishing the 15 from the other morning. All right. So the table above gives selected values of a differentiable, which means it's a smooth curve. No crazy stuff. No crazy turns or jumps or whatever. Is everybody with me? And then it's decreasing, so it's going down, and it's not going to stop going down. It doesn't go back up for a second. It just goes down. All right, and they give you its derivative. If f to the negative 1 is the inverse derivative rule, find the value of the inverse. All right, who remembers the derivative of the inverse?
1 over f prime of the inverse.
All right, you should have this memorized. It's 1 over the derivative of the,
Inverse.
1 over the derivative of the original function evaluated at the inverse. Say it with me. What's the derivative of the inverse? 1 over the derivative of the original evaluated at the 1 over the derivative of the original evaluated at the inverse. Okay, here we go. If you want to do the inverse derivative, there's a prime. This is a prime. At 2. So it'd be 1. Yeah, it's pain to be there. It's 1 over the derivative of the original evaluated at the inverse of 2. Now remember, the inverse is when you go in reverse. So it's going to be 1 over the derivative of the original evaluated at the inverse at 2. First of all, let's find the inverse at 2. So the inverse at 2, all right, would be, where does f of x equal to? That would give you where f inverse of 2 is. Okay? Remember, you switch x and y when you're doing an inverse. So if you want to find the inverse at 2, you got to figure out where f of x equals 2. Here's where f of x equals 2. So f of 1 is equal to 2. Do you agree? So f inverse of 2 is equal to what? 1. So we know that has to be a 1 down here. So now it's just the reciprocal of the derivative at 1. Well, what is the derivative at 1? So the answer is going to be negative 1/8 b. Okay, good one. 28. Ooh, related rate problem. You can just tell. And there's the ladder problem, and they even have it drawn for you. The top of a 15-foot long ladder. How long's the ladder?
15.
Is that distance ever going to change? Is the ladder always going to be 15 feet? So can you plug in for it before you even do the related rate, before you even take a derivative? Yes, because it's constant. Resting against the vertical wall with the bottom of the ladder on level ground. We did this exact related rate before. It was on those 38 problems I assigned. Okay, 15-foot long ladder rests against a vertical wall with the bottom of the ladder on level ground, as shown above. If the ladder is sliding down the wall at a constant rate of 2 feet per second, so this distance right here, we'll call that y. So what is dy dt? What do they say about dy dt?
2 feet per second.
It's going down at negative 2 feet per second. Why is it negative?
It's going down.
It's going down. That distance is decreasing. Oh, they're jerks here. At what rate in radians? What? In radians per second is the acute angle between the bottom of the ladder and the ground. So they want this, theta. So they want d theta dt, which means you don't get to use Pythagorean theorem. You got to use SOHCAHTOA.
Oh, shucks.
Yep. So we've got theta, so we need to find d theta dt. Okay? At what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing at the instant when the bottom of the ladder is 9 feet from the wall? So when x equals 9 feet, I'm going to say this is x. Because it says when the bottom of the ladder is 9 feet from the wall. So when this gets to 9 feet. All right. You are going to need Pythagorean theorem to figure out what y is. Because you know what x is. X is 9. You know what this is 15. You're going to need to know when y is whatever. Or just use a different trig ratio. I guess it's up to you. All right. We want to find theta. Actually, I want to find d theta dt. I need to relate theta to the other rate that I know. So I can't use x because I don't know the rate of change for x. Do you know how fast x is changing? So you've got to involve theta and y. All right, SOHCAHTOA here. It's a good chance to review this. And there's usually one problem on the exam where you need SOHCAHTOA. Okay, which one's going to relate theta to y?
The first one?
The first one. I'd use sine. Opposite over hypotenuse. And the reason I want to use the one with the hypotenuse is because you know the hypotenuse is what?
15.
And it never changes, so you can plug it in. So it'll be sine of theta is equal to y over 15. Why can I plug in the 15? It's constant. Now, take the derivative. What's the derivative of sine? We take the derivative of both sides with respect to time. What's the derivative of sine? Cosine theta times d theta dt. Equals, what's the derivative of 1/15th y? 1/15th times the derivative of y, which is what? dy dt. Got it. Now, you know dy dt. What is dy dt? Go back up there. What was dy dt? -2. So you got 1/15th times -2. You want to find d theta dt. Here's the crux move. This is where some of you are going to be bothered by trig. You got to figure out cosine of theta. All right, cosine. SOHCAHTOA. Go back to SOHCAHTOA. What was cosine? Ka. Adjacent over hypotenuse. Do we have the, if this is theta, do you have the ADJ?
Yeah.
You don't.
No.
That is 9.
Oh, yeah, you do.
Yeah, I was gonna say, don't you have?
When x is what?
9.
9. You do. You have x is 9. Great. All right, so what's cosine?
9 over 15?
Cosine theta would be 9 over 15, which will reduce to what?
3/5?
3/5 with, by the way, this is a 3, 4, 5 triangle. If you had to find y, what would y be? It would not be 4. It'd be what? Nope.
12?
It'd be 12 because they're all multiplied by 3. Because it's a 3, 4, 5 triangle. It's a multiple of a 3, 4, 5 triangle. It's a 9, 12, 15. But you don't need y. You just need x. And they gave you x. So cosine was 9 over 15, which reduces to 3/5. So we can plug 3/5 into cosine. There we go. So we've got 3/5 d theta dt is equal to -2/15. How do we solve for d theta dt? Multiply by the reciprocal, 5/3. So d theta dt will equal, let's see here, 5 goes into 5 once, 5 goes into 15 3 times. I'm going to get -2/9, I believe. And does it make sense that theta is going to be decreasing? Look at this. As the ladder slides away from the wall, is that angle going to get smaller? Yeah. So the answer is A. All right, let's go to the 2016 calculator. And this is probably where some of you need something because it's what your homework was. Most of you probably got the non-calculator done but need the calculator. Okay, grab a calculator because you need it. That was nice of Kristen. All right, here we go. Calculator, here we go. First one. The directions are the same every year. When you get to the calculator, the exact numerical value of the correct answer does not always appear in the choices given. When this happens, select from the choices that best approximates. And how many decimal places do they go to? 3. Otherwise, unless otherwise specified, the domain of the function is assumed to be the set of all real numbers. And then the inverse trig function may be indicated by f inverse or arc. So if you have inverse sine, you can have, look at this, you can have sine to the -1, which is inverse sine, or you can have arc sine. Arc sine or inverse sine mean the same thing. All right, here we go. This first one. Let's see if we can get through most of these. I think there's like 15 or 16. You can put it right there. 17. Here we go. Let's see how many we can get through. The graph of function f is shown above. Please make note of what they're giving you. Which graph are they giving you? F.
Did we
Which-
start this at all, or is this?
Yesterday. It was homework. I gave you 2016 for homework last night. Here we go. So you probably did the non-calculator in class. And I don't know how far you got with your partner. Okay, you had all class period to work on it. We didn't watch a video yesterday. It was just work on this, wasn't it? Yeah. So the graph of function f is shown above. Which of the following does the limit not exist? Which one, what value is the left not going to equal the right? What's the only two places you're worried about here? Look at it. What two places would you be most concerned about the limit? 3 and I wouldn't worry about 1. 1 definitely works because the left and right do agree, don't they? Now it's a corner, so when you do the derivative of it, it'll be undefined. But right now, 1 is continuous. Do you agree?
Yeah.
So that's fine. The only place I'm worried about is where I have discontinuity. We have a discontinuity at 3 and we have a discontinuity at 5. Which one, though, is the left not going to equal the right? 3. The left equals 2 here and the right equals what? Negative infinity. I'm going to say it again. The left is equal to what? The limit as x approaches 3 from the left of f of x is equal to what? And the limit as x approaches 3 from the right of f of x is what? So that's where the left and right do not agree. So that's the one where it'd be D and E. So the answer is, which of the following does the limit not exist? 3 from the left exists. That's 2. That was a little bit of a trick question. So the answer is D, because it's where the left and right agree.
That was a calculator problem?
Yep. Just because it's on the calculator doesn't mean you're going to need the calculator. In fact, most of the problems, watch, keep a tally, put a tally mark down. We're going to put a tally mark down. We're going to keep track of the ones you don't need the calculator for. So far, one problem you did not need the calculator for. If f is a continuous function on the closed interval, guess what? IVT, intermediate value theorem, and EVT apply. Which one does not work? MVT, because it needs to be continuous and what? Differentiable. If f of 1 equals 10 and f of 3 equals 18, this just feels like an IVT problem, because they're telling you it equals 10, and then you're telling you it equals 18. So there's an in-between value that you're trying to prove. Which of the following statements could be true? All right. Would I be able to show that there is a value between 10 and 18?
Yeah.
That's what IVT says, that there has to be, that in between 1 and 3, there has to be, you're going to have to take on every value between 10 and 18. Just think about it. If you're at 1, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, 110, and then 318 is way up here. You're continuous. I don't care what you do. You're going to take on every value between 10 and what? Between 10 and 18. All right. Does it mean that f of 2 has to be between f of 10 and 18? Maybe. Is it possible that it went down at 2 and then went up?
Yeah.
So A is not true. I don't know for sure if f of 2 is between 10 and 18. Could be. I am going to take on every value between 10 and 18, but I don't know if f of 2 is going to be between 10 and 18 because it could have dropped down first and then went up. Okay, and then they didn't tell you anything about increasing or decreasing. Is B, does f have to increase over the whole interval from 1 to 3? I just proved that's not true. Is it possible for it to decrease and still go up to 18? So that's not true. F of x has to equal 17 for at least one solution between 1 and 3. Is that one true? You would have to go through 17. Why? Because you went from 10 and 18, you had to go through 17. So the answer is clearly C. This IVT says nothing about the derivative. This is doing like something with mean value theorem, but we can't do mean value theorem where the slope of the I rock equals the A rock. So that's out. And this right here, I don't know if the area under the curve is greater than 20. Could it be the area under the curve is greater than 20?
Sure.
Good.
Could, but does it have to be?
No.
No, so the answer is clearly C. Did that require a calculator? 2 problems, no calculator so far on the calculator part. Now this one looks like, all right, I'm going to explain this, even though I'm teaching this next week, probably Wednesday or Thursday. I think it's going to end up being Thursday. R is the region bounded by the graphs. Watch this. It's so simple. It's going to seem crazy because you've never done it before, but when you get to it, you'll have a preview of this, and when you hear it for the first time, you're going to be like, okay, I kind of remember I'm talking about this. Let R be the region bounded by the graphs of e to the x. Can you draw e to the x?
This is the
J curve.
J curve at 0, 1. Everybody draw a J curve at 0, 1. You guys get a preview of something so sweet. So there's a J curve. Done. What's y equals e to the 3rd power? Is e a constant?
Yes.
Is 3 a constant? Type in e to the 3rd power. Go second ln. Everybody do this with me. Second ln and to the 3rd power. It's just a horizontal line at 20 point something. Okay? It's a horizontal line up at 20 point something. So e to the 3rd is way up here. Does everybody agree? Y equals a constant is a horizontal line. Now pay attention. Let R be the region bounded by the graphs of e to the x, e to the 3rd. You have a calculator, don't you? Could you type all 3 of these equations into y equals? Yep, and then x equals 0. What's x equals 0? What kind of line is x equals 0? Not horizontal. Vertical line. Okay? X equals 0 is a vertical line. So we have these equations. We have this one's y equals e to the x. We have this one's y equals e to the 3rd. Y equals a constant, it's a horizontal line. X equals a constant is a vertical line. We have e to the x. Let R be the region bounded by these 3 graphs. Do you see where the closed off fence is going to be? Do you see where your dog would have to play? Right here. Does everybody see this?
Oh, baseball diamond.
Yep, kind of a baseball diamond. Now, let me explain this. It's going to be wild. Listen carefully. Which of the following gives the volume? We're going to talk about volumes next week. Formed by revolving that region. I'm going to take that red region and I'm going to revolve it around the line y equals -1. Y equals -1 is way down here. Do you see this?
We haven't done this.
Nope, we haven't, but I'm going to teach you on the fly.
Is this
Okay,
the
just watch.
lampshade problem?
Huh?
Is this the lampshade problem?
This is the lampshade problem, or it could look really wild. This one looks really wild. Now, what you're doing, and we're going to teach you next Wednesday. Okay, you'll learn how to do this next Wednesday. So you're taking that region and revolving it around this. You're rotating it. So imagine this area getting rotated around this. Okay? This area, and I actually have a thing that 3-dimensionally shows this.
I can't visually see this. Like,
No, it's kind of crazy. So if you took this and rotated around, it would be like a solid bowl that you carved out a circular part out of it. So it almost looks like a cake that kind of dives in. Like you ever seen like those pound cakes that kind of dive in the middle?
Oh, yeah.
So you don't have to be able to visualize it to do it. You don't have to draw it. You don't have to visualize it to do it. Here's all you need to know is that if I'm going to take this volume, you do the same thing that you do with area under the curve. What you're going to do is you're going to imagine, watch me carefully. I know this might be hard to pick up on, but just go with it. You always go from the axis of revolution, what you're rotating around. And you're going to measure from that what you call the outer radius, which is going to be top minus bottom. There's an outer radius. And then there's going to be an inner radius, which is to the closest point to the region. Do you see that? And what happens is, remember when you do area under the curve, it's an infinite number of rectangles. These rectangles become discs. And as you rotate one rectangle, think about it. If you rotated one rectangle, wouldn't it be a hockey puck? Think about it. If you had a rectangle, watch this. If I rotated one rectangle, wouldn't it just become a cylinder? A hockey puck. So those infinite number of rectangles become an infinite number of cylinders, and you'll see this next Wednesday. And what you do is you're going to figure out the area or the volume of one of these hockey pucks. But there's a part that you have to carve out because we only want the red region. So you're going to have to take this outer region minus this inner region. And so there ends up being a formula that you will learn next Wednesday. It looks like this, and it's some of your last formulas you learn. It ends up being this. It's called the area of a washer. And it's a washer because you have what's called a disc and a washer. A washer is a disc with a what in it? And you know there's a hole because there's this part, this white part you got to subtract out. Do you see it? So what it ends up being, there ends up being a pi. And the reason it ends up being a pi is because it's a cylinder. It's pi r squared h. This is the volume of a cylinder. The radius ends up being this top minus bottom. But there's the radius of the first cylinder. So what you're going to have is a definite integral from a to b of an outer radius squared. So I call that big R. That's because of the r squared. Does everybody see that? Minus, there's going to be an inner radius squared. So I call that little r. And then people are like, well, what about the h? Well, the h ends up being the width of these infinite number of rectangles that you rotate. So the h is just the width of the rectangle, which we always call dx, because that's approaching 1 anyway. So if you get an infinite number of rectangles, you get an infinite number of cylinders, which fills in the volume. So this is kind of where this comes from. I'm going to teach it to you next Wednesday, so don't freak out. So here's how you'd actually do it. They only want you to set this one up. So you're just going to take the top function minus the bottom function. What's this top function? Look at it. We labeled it. What's this top function? So this big R of x is going to be e to the third minus, what's the bottom function down here? Negative 1. We're measuring to this thing we're rotating around. See it?
Okay.
So that ends up being e to the third plus 1. That's your outer radius. So here we go. We've got volume is equal to pi times a definite integral from a to b. We'll get to that part in a minute. We're going to have e to the third plus 1 squared. Minus the inner radius. Let's do the inner radius. Let's do this one. Little r of x. What's the top function? E to the x. The curve, the j curve. Okay. Minus the bottom function is what again? So you get e to the x plus 1 for that part. So there's my little radius. So that ends up being e to the x plus 1 squared dx. And the only thing you've got is the pi, and it looks like they're all from what? And I'll tell you where you get the 0 to 3, because you're going from 0, clearly 0, up to where?
The intersection.
0 to what?
3.
Because that's where e to the x and e to the third cross. That's kind of duh. E to the x would cross, like think about, where does e to the x equal e to the third? Where the exponents are equal, obviously. So the answer would be, what is it going to be here? E. Now, you haven't learned how to do it, but how many of you followed that kind of? Did you kind of follow it?
I don't really get the hockey puck thing.
I'll show you on Wednesday next week, because I've got a thing that 3-dimensionally shows it.
I'm tracking the formula, but the
Yeah. When we got to that.
But
this-
just thinking.
You have to imagine this right here. Watch this. Remember the rectangles eventually are approaching 0. But imagine it like when you did a Riemann sum with just like 5 rectangles. Do you see that rectangle? If you were to take that one rectangle and rotate it around this, if you take a strip, a rectangular strip, take a piece of paper, look at this. If I rotate it around an axis of revolution, isn't that going to become a hockey puck? You see it? Rotate it.
Like you mean like
I'm rotating it around, an axis of rotation.
It's game
So just keep
area.
it.
Yeah, so this area of this rectangle gets rotated into 3 dimensions, so it becomes a hockey puck. See it? It's like a tire wheel. All right, here we go.
Did we technically use the calculator?
Huh?
Did we technically use the calculator?
Did not use the calculator.
I looked up something on it.
Okay? You may have used the calculator a little bit. You didn't need to, though. because it was common graphs. The number of people who have entered a museum on a certain day is modeled by the function f of t. The number of people who have entered a museum is modeled by f of t, where t is the hours since the museum opened that day. The number of people who have left the museum on the same day is modeled by g of t. If f prime of t is equal to this, and g prime of t, so f of t represents how many people enter a museum. So what does f prime represent?
The rate they're entering.
The rate at which they enter, how fast they enter. All right, g of t represents the people who have what? Left. So what does g prime represent? How fast they leave, the rate of people which leave. So at what time from 1 to 11 is the number of people in the museum a maximum? Okay, here's what you want to do. So it's actually pretty simple. If you want to do a maximum, you need the derivative. Do you have the derivative of f prime of t? Do you have the derivative of g prime of t? What's going to represent the total people in line, the rate of the total people in line? F of t is people entering minus g of prime of t. I want to maximize this. So all I got to do is set this equal to what? You got the derivative. You need your critical values to find your maxes and mins. You set it equal to what? All right, now you need your calculator. All right, so we're going to take f of t, which is 380. Here's what I would do personally. I would put I'd put f prime of t into y1. Everybody put f prime of t into y1. 380 times 1.02 to the t power. Okay? So go to y equals, put f prime into y1. Are you good? Put g prime in where? You might need to use alpha x to get that really complicated fraction in there. So you have 240 plus 240 sine of pi times t minus 4 divided by 12, close the parentheses.
Make sure your calculator's in radians.
Make sure your calculator's in radians because the MCA kids used it yesterday. Everybody got it typed in correctly? Now here's what I do. I go to y3. Go to y3. Go vars. Y vars. Function. Y1. Minus vars, y vars, function, y2. Show your neighbor.
Wait, what did you
Well,
say?
we did that y3, right?
Y3, you put y1 minus
It's
y2.
gonna graph it. It's gonna graph the
It's going to graph the difference of y1 and y2. Yep. Now, I want to know when the number of people are going to be a maximum. Okay? So I want to know where it goes from. Listen, turn off your graph for y1 and y2. Does anybody know how to turn off the y1 and y2 graph?
Select the
Unhighlight the equal sign for y1 and y2. Unhighlight the equal sign. You doing it?
Oh, that was an option.
Mm-hmm.
Push
Now
graph.
it's
Now graph. We're only going to graph y3.
This is wild.
Can't even really see it.
oh, hello.
Okay? Is it hard to see? You're going to adjust your window. Look, guys, it's up 240, up 380. So I'd probably make my window from 0 to 500 for the y. So go to window and change the y min and y max. And then the x min and x max, you automatically know what to change that to. What should you change the x min and x max to? 1 to 11. So x min should be at 1. X max should be at 11. Y min, maybe, I don't even know if you need to go down to 0. We can go 0 to go 0 to 600. Go 0 to 600. You probably can see it from 0 to 500, but 0 to 600 is safer. Do you see it?
Sure, what am I supposed to see?
That's just a line.
the wonky triangle.
Do you see it?
So then what is it?
All right, now here's the deal. You want to, I should have said y min and y max. You want to see it from,
Hold up.
What does Bjorn's look like? His is like inverted. Is it?
go to y equals and check your y equals with hers.
Oh,
To the x?
Yeah, it's to the x power. Now, Kate asked the most important question. What are we looking for? Well, we want to know where this equals what?
0.
So I should be able to see the x-axis. So for my 0 to 600 deal, I shouldn't have done that. Maybe go negative 100 to 600 so I can see where it crosses the x-axis. Or negative 100. So do your y min, make it negative 100. And your y max, I don't know, 500, whatever, who cares? I guess you don't even.
Are x min to be more than 1 if we want to see where it's at 0?
Say that.
No, we want to see where it crosses 0, where it crosses the x-axis. So we want to see where y is equal to 0.
How is that the maximum?
What's a window we should do? Oh man.
Guys, change your window so that you only care about values of t between 1 and 11. That's your x-axis. Your x-axis is the t-axis. So change your x-min to 1, your x-max to 11. Are you good with that? You need to see where it crosses the x-axis. So I need to be below the x-axis. So do like negative 100 or negative 200. I don't even care. Okay? Do your y-min at negative something. All right? And then do your y-max at what? I don't care. 200. Just as long as you're above and below. Y min, Y max. Just make sure you're way below. You could do whatever you want. You could do as long as you could do negative 2 to 2. As long as you're below and above. And you can see, do you see where it crosses the x-axis?
Yes.
Okay? As long as you're a little bit below, a little bit above.
It's B.
All right. You do second trace. By the way, hold on.
Wait.
Does that graph go from above to below?
Yeah.
So is that a max? Is this the derivative? Are we looking at a derivative? So the derivative is positive above, the derivative is negative below. So does the original function go from increasing to decreasing?
Mine's still cooked.
Yes, increasing to decreasing. So do second trace 0.
Mine's going
What
from
did it
decrease to increase.
You didn't type it in right. That's a user error.
Can you?
I'll do it after. I'll do it after. 80, let's do 2 more.
What was the
B.
B. It was simple, just says second trace 0. 7.88. All right, let's do 2 more. Number 80. F is continuous on the closed interval from 0 to 4. Values of f and f prime selected for values of x are given in the table above. If the definite integral from 0 to 4 of f prime of t is equal to... What are they giving you here? What is this? They're giving you the definite integral from 0 to 4 under f prime of t dt is equal to 8. What is that? What is it? Area under the curve. It's displacement. Very good. So if I want to calculate f of 4, here you go. This is all you need. This one's so easy. You need start plus displacement. You need to know where it starts at 0. And then all I have to add in is how much it got displaced from 0 to what?
4.
We already know how much it got displaced from 0 to 4. How much did it get displaced from 0 to 4? 8. So if you know where it starts, will you know its new position? What is f of 0?
5.
What's 5 plus 8? The answer is E. Start plus displacement. We'll do that a lot over the next 2 weeks.
Put that like calculator part.
Yep, didn't require a calculator, did it? How many problems have not required a calculator? How many problems have required a calculator? 1. Last one.
Whoa.
That's a slope field.
Skip it.
Why? It's not. This one's actually pretty easy.
Alright.
The slope field for the differential equation is shown above. Y equals f of x is a particular solution to the slope field at the point negative 1, 2. Everybody find the point negative 1, 2.
It's an L curve, it looks like.
Negative 1, 2 is right here. So the curve's going to go in here somewhere between. Would you agree?
I guess.
Yep, somewhere in there. All right, h of x is equal to 3x times f of x. They want you to find h prime of negative 1. You with me? Okay. So h prime, let's do the derivative. How do you do the derivative of this? What rule would you need? Product rule. What's the derivative of the first function?
3.
3 times f of x plus 3x times f prime of x. Very good. Now, they want the derivative at negative 1. So I just want h prime of negative 1. So we're going to have 3 times f of negative 1 plus 3 times negative 1 times f prime of negative 1. And they gave you the slope field, so we know what the slope of negative 1 is going to be. Here we go. So we're going to have 3 times, what was f of negative 1? I believe they gave you that. Y equals f of x is the particular solution to the point of the differential equation 1, negative 2. So what is it?
2.
2. All right, 3 times negative 1 is minus 3 times f prime of negative 1. What is the slope? What is the slope field saying that at negative 1 the slope's always going to be? Look at it. It's just a shift up or down. But what's the slope always going to be?
Negative.
Look at the slope. What is the slope there?
Negative 1.
It looks like it's a slope of what? Down 1, right what? Down 1, right what? So it looks like it's a slope of what?
Negative 1.
Negative.
Yeah.
1/2.
Negative 1/2.
Rise over run. Down 2, right 1. So it's a slope of what? Negative 2. I was trying to get it out of you guys. All right.
Down 1, so then we got.
Oh, sorry.
You did say
I did say down 1?
Yeah.
Okay, then totally my fault.
Yeah.
Totally my fault. So we get 6 plus 6, which is what?
Wait, 12?
Yep.
I thought it was -6.
Yeah, 6 plus 6. Last one, 82. If f is a... Did that require a calculator? No, did not require a calculator. If f is continuous from... if f is a continuous function such that f of 2 equals 6, which of the following statements must be true? So if f is a continuous function, which means no what? It means the limit must what? The limit as x approaches 2 of f of x must exist. It must mean the function is defined. What's the function defined at? So the limit value has to equal the what?
Function's value.
So what does the limit as f of x have to equal? 6. So this right here says what would happen if you do the limit of like 2x. Okay, I think the answer is going to be
We don't have any power hour today, right?
no.
So that's our first hour bell.
Yeah, I think the answer is it D?
Right,
That's
I
our
need to
first
get
hour bell?
breakfast or else I'm cooked.
Is it D?
I have no clue. I don't know.
Go look at the answer. I think it's D.
Okay, sure.
Or no.
What did we see?
I think it has to be.
Does it equal 6?
Yeah, but that's that's alternate form of a derivative.
Oh, yeah.
That's alternate form of a derivative. That's actually doing the slope.
E, it says.
Huh?
It says E.
Oh, it has to be E because the rules for limits is the power has to be on the outside. So you can do the limit of a power if it's on the outside. So the answer is E. That's a property of limits.